Hi and welcome. In this video, we are going to discuss about Codechef December Long Challenge Question Addition, problem code BINADD, binary addition, BINADD. Okay, the question is, recently Chef studied the binary numerical system and noticed that it is extremely simple to perform bitwise operations like AND, or bit shift, non-negative integers, while it is much more complicated to perform the arithmetic operations. So for addition, he came up with this algorithm. Okay, given two numbers a and b in its binary format, what he is doing, while b is greater than 0, u equals to a XOR b, v equals to a and b, a equals to u, b equals to v into 2, and return a. I will explain you this, do not worry, I will explain you this. Okay, now Chef is wondering how fast this algorithm is. Given the initial values of a and b in binary representation, he needs you to help him compute the number of times this while loop will run. Okay, now if you run this while loop alone, you will be able to solve 50% of the question. Okay, just fast input output, and you will be able to solve 50% of the question by just implementing this algorithm as it is. Okay, but we need to solve the 100% of the question, so we will see the underlying logic behind it. Fine, so let me explain you first what this algorithm says. So here, if a is 1 1 1 0 0 and b is 1 0 1 0, okay, a 0 will be added. Now what the algorithm is saying is, first point, while this b is greater than 0, okay, first point, in u have to do a XOR b, okay, in v we have to do a and b, okay, and then a u value will again go to a, and b value will become b into 2. Okay, so what is these lines? So we know about a XOR b, we know about a and b, u is shifting to a, u is copying to a, and v into 2 is nothing but it is shifting a bit by 1, left shift by 1. Okay, b into 2 is nothing but left shift by 1. Fine, now when we add these two numbers, okay, so this a and b is nothing but carry. This is nothing but the carry generated at that particular step. Carry generated at that particular step is nothing but a and b. If I add these two numbers directly, what is the answer? It is 0 1 1 1 and 1 is 0, 1 carry, 1 and 1 is 0, 1 and 1. This is the answer, correct? Now let's follow these steps, and one by one we will see first what is this algorithm, then we will see what is the pattern behind it. Okay, now it is nothing but 1 1 1 and 0 0. Okay, 1 and 1 1 0 0, and it is 1 0 1 0. Fine, if it is a and it is b, let's follow the steps one by one. Fine, so the first step is a XOR b, u will become a XOR b. So XOR is simple. Okay, 1 XOR 0 will give me 1, and 0 XOR 1 will give me 1. Rest, if both are same, it will give me a 0. Okay, so pretty simple. So this will give me 1, this will give me a 0, this will give me a 1, this will give me a 1, and this will give me a 0. Correct, we will become a and b, so 0 and 0 0, 0 and 1 0, 1 and 0 0, 1 and 1 1, 1 0 0. Fine, so just follow these steps and the addition steps also. Follow these steps and the addition steps also. Okay, in the third step, a will become u again, and in the fourth step it will be shifted by 1. This one will be shifted by 1 position, 1 0 0. Now just see when we add what is happening. When we add what is happening, so 0 0 is 0, it is 1, it is 1, it is 0. This carry goes here. Okay, this carry goes here. Fine, so it is nothing but 1 is the carry and 3 zeros. 1 is the carry here. Am I correct? 1 is the carry here, and it will be how much? 1 2 3 4 zeros here and 4 zeros here. So b represents us the carry. B represents us the carry. Okay, and here it will be 0 again and 1 again and 1 again. We will see this also in the next step. Now this steps again repeat itself. Now in the repetition, this is the new a and this is the new b. So what is a XOR b will give me now? It will be 1 1 is 0, 0 0 is 0, 1 0 is 1, 1 0 is 1, and it is 0. What the a and b will give me now? 1 1 is 1, and rest all are zeros. Okay, third is a equals to u, and fourth step simply means b shifting. B shifting by 1 will give me no zeros. Correct? So as you can see here, this u was nothing but this. Correct? This v, this is v, this v was nothing but when one was here, that is a carry, that is a carry. So at each step b will represent the carry, okay, and the XOR will represent a simple addition without the carry, okay. B will represent the carry. Fine. Now when you follow this algorithm, the 50% of the question you will be able to solve, okay. 50 marks you will get, 50% of the question you will be able to solve. Now let's see the next 50%, how to do the next 50%. Fine. This is a very important steps. There is a reason I have explained you these steps, okay. These are important in solving the question. Fine. Now as you can see here, whenever a carry is generated, okay, this carry is generated, it is shifted by one position. It is shifted by one position. Now this shift is actually very important. This shift is actually very important, okay, because when this one goes out, then b will become 0. By shifting by one itself, shifting by one position on the left, at some point this one will go outside, correct. This one will go out of this range, then the b will become 0. So we need to find out that how many times will this one be shifted, or any one be shifted, okay. How many times will the carry be propagated? If we can find it out directly, that how many times that the carry is propagating, okay, without doing these all steps, just directly if we can find out that how many times the carry is propagating, how many maximum number of times the carry is propagating, okay, that many times this loop will run, that many times b will never be 0, okay. Once the carry propagation is complete, at that moment the b will become 0. So how can we directly find out that this part, that how many times the carry will be propagated, okay. So this is the problem statement, that just find out directly using these two initial values, find out directly how many times the carry will be propagated and nothing else, okay. Let's now begin with that part explanation and then it will be over, okay. Now if these are my a and b that are given to me initially, let's do this step by step, okay. Now what will be the new a? New a will be nothing but the XOR values. So the XOR value will be 1 0 0 1 1 0 1 0, okay. And the new b after a and b, after a and b and shifting by one position and shifting by one position, what it will be? It will be nothing but 1 will be here, okay. Let me just show you if you will get confused. So here after shifting, before shifting the position, this will be v, correct, and a and b will be nothing but 1 and 1 is 1 0 0 0 1 0 and 0, correct. Now shift by one position, it will be 0 1 0 0, this is 0 0 0 1 and 0, correct. Now see, this is by shifting one position. Now these are my new a and b, these are my new a and b. Now perform the AND operation simultaneously step by step here also, okay. So 1 and 1 is nothing but 0, 1 and 1 is nothing but 0, and 1 will be here, 1 will be here, and 0 and 0, and this will become 1, am I correct, and this will become 1, fine. This will become 1, this will become 1, 1 and 1 is 0, 0 will come here, 1 and 1 is 0, 0 will come here, and 1 will be printed. This is our addition. Now let's see the steps. Now once we perform the AND operation here again, now XOR operation will be performed in the next step. So u will become this one, a XOR b, am I correct, a XOR b. So it will be 0 1 1 1 0 0 0, and just concentrate on this. It is 0 1 0 will become 0, 1 0 will become 0, 1 0 will become 0, am I correct, and here 1 1 will become 1, and here it will become 0. So the carry that was generated in the previous step actually here became 0. The carry that was generated in the previous step becomes 0. It didn't propagate all the way along to the end. The carry that was generated didn't propagate at the end. It became 0 in the next step only. It became 0 in the next step only. What may be the reason behind that? What can be the reason? The reason behind that is for this carry to propagate further. For this carry to propagate further, the XOR value should be what? The XOR value should be 1. For this carry to propagate further, this XOR value should have been 1. If this XOR value should have been 1, then 1 and 1 will give me a 1, correct? But this XOR value is 0. So if you want your carry to propagate further, that means the XOR value should be 1. the XOR value of adjacent number should be 1. Correct? This step is generating me a carry. 1 and 1 is generating me a carry. But this carry to propagate further needs an XOR value of 1. But an XOR value of 0 was present. Okay? Therefore 0 and 1 became 0. But we needed an 1. So if a 1 was present, for example, if this was not 0 but this was 1, correct? If this was not 0 but this was 1, now 1 and 1 will become 0 and the carry will be propagated further. As you can see here, the carry is propagated further. A new carry is not generated, but a carry is propagated further. Am I correct? If this was 1, the carry would have been propagated further, but here the carry didn't propagate further. The reason being, here it was a 0 and 0 will cover it, and the carry will not be propagated any further. This carry that is generated right now. Okay, carry is generated when we have two ones together. Correct? Now a carry is generated here also, that is here. Now we have a 0 1, and now you can see the carry is again propagated. Okay, so when we have a 2 1s and a carry is generated, if we have 0 0, the carry will not be propagated further. Okay, but we need the carry to be propagated further. Okay, we want to know that how many times this carry will be propagated. Once we know that how many times the carry will be propagated, we can directly get our answer. Okay, so 1 1, if it is 0 1 or 1 0, the side of it, the carry will be propagated. Okay, the carry will be propagated here, the carry will stop. Fine. So we need to know that how many times this carry is propagated. Once we know that how many times this carry is propagated maximum, okay, at that is the number of while loops running. Okay, because B is nothing but carry. B represents nothing but carry. Okay, so how many times this carry can be propagated, that is the final answer. As you can see, this one is here. When we shift it, this one will become at the end. So as you can see, the one is shifted from the second last position to the last position. Okay, and why it can be shifted? Because it was a 0 1, and 0 XOR 1 gives me a 1. Okay, fine. So XOR became 1, carry was already 1, so 1 and 1 becomes a 1. Okay, therefore the carry is propagated further. We need XOR to be 1 to propagate the carry further, and that was the logic behind the question. Okay, now I will give you many examples just to show you that this is correct. Fine, let me give you some examples now. If this is my A and B, okay, so this will generate me a carry, am I correct? These two will definitely generate me a carry. So let's increment this, the count as 1. Okay, for this one, for the first one, let's increment the count as 1. Fine. So will the carry be propagated further? Yes, because there is a 0 1, the carry will be propagated further. How many times the carry will be propagated? The carry will be propagated twice. Okay, so a carry will be generated here. Definitely B will have a carry. Okay, it will be propagated twice. So how many times? Total 3 times it will definitely run. Correct. 3 times, because of this 1 and 1 that was generating a carry. 3 times the carry will be definitely running. Fine. Now let's come here. So this will also generate me a carry. Correct. So again, let me make another count variable. Count 1 will become 1. How many times will it be propagated? Here, here, and here. It will be propagated 3 more times. Okay, so count becomes 4. So maximum, in the maximum case, how many ones will we get? How many times the loop will run? In the maximum case, the loop will run 4 number of times. Okay, the B loop will run in the maximum case how many times? 4 number of times. That is the carry that is being generated, and the carry that is being propagated. Okay, now is it true that this loop will run 4 number of times, or any other value can also satisfy this? Let's see that point now. Now a carry will be generated here, propagated 3 times. So total how many times? 4 times. Okay, and this will not make the B 0, because when the carry is propagated again and again, at the end 1 will come. Okay, to make it 0, it will also run 1 more number of times. That is, B will become B left shift by 1. Correct. So this one will go out. This one will go out at the end. So the answer will be simply 4 plus 1. So the answer will simply be 4 plus 1, because see here, 1 and 1 is 0, correct? Just start from here only. 1 and 1 is 0, 1 carry. 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 Okay, see, this is also coming because this was propagating a carry, so there is an extra one. Okay, so therefore we are adding it out. So 4 plus 1 simply becomes 5. Fine. So this was one of the case. What can be the other case? The other case can be if we have 1 0 0 1 1. Okay, and here also it is 1 1 and 0s 1 0. Fine. Now what will happen? Just see here. What will be 1 XOR 1? 1 XOR 1 and 1 will definitely give me a 1. Correct? Fine. Will definitely give me a 1. So write the XOR here. XOR will give me 0 0 0 1 1. And will give me 1 and 1 is 1, 1 and 1 is 1, rest all are zeros. Okay? Correct? Now add will give me add. Now I'm adding. So 1 and 1 will become 0. Carry will come here. This will become a 1. This will become a 1 because there are 3 ones. So 1, 1 and 1 at the end. Correct? So what is the carry? Which carry is propagated? This one or this one? Which carry is propagated? Just think about it. Which carry is propagated? As you can see here, when 1 and 1 was 0, okay, a 1 was carried. 1 was carried. Okay, when this end will shift, it will become 0 1 1 0 0. Okay, and XOR was 1 1 0 0. Correct? Now this is my A, this is my B, and as you can see right now, what it will happen? What will happen? As you can see right now, 1 and 1 was 0, 1 and 1 was 0. This all value became 0 at this position only. This all values became 0 for end. That is B becomes 0. There, see, there is no end here. The B becomes 0 at this initial position. Correct? So because after 1 1 there was no 0 1 or 1 0 to propagate the carry forward. Okay, here there is nothing. Here also there is no 0 1 or 1 0 to propagate the carry forward. Therefore only 2 times the loop is running. That is, for the first time this, and for the second time to make it 0. Okay, when we shift it, okay, the first time was this, correct? And the second time when we come here, it will become 0 directly. Okay, as soon as we end it, it will become 0. So it will run 2 number of times. First time when the carry was generated, and for the one time to make it 0, the left shift and make it 0. So how many? 2 number of times. Okay, I think you are getting the point now, that the point is very simple. Just for each and every 1 1, just count how many continuous 1 0 or 0 1 are present. For each 1 1, count how many continuous 1 0 or 0 1 are present. Okay, this value, whoever has the maximum value, that is the answer, plus 1. Whoever has the maximum value, that is the answer, plus 1. Why plus 1? Because one more step is needed to make the last one go out. Okay, fine, understood? So all we needed to calculate was the maximum times the carry will be propagated, and the maximum times the carry will be propagated depends on 1 1, okay, the carry generator, and 0 1 or 1 0, the carry propagators. Okay, the XOR value 0 1 or 1 0, only these two will give me a 1. Okay, and carry came from the behind, so it will become 1. Fine, so 1 and 1 will become now a 1 again, so a carry is propagated. Okay, now if this becomes a 0, that means the previous carry was not propagated further. Okay, that we do not want, correct? So only 0 1 and 1 0, because their XOR values are 1, and a carry is coming from behind by shifting 1 positions to the left each and every time. Okay, therefore what we found out, that after 1 1, just calculate how many 0 1 and 1 0 are there simultaneously. Fine, let's see one more example, and that will clear all the doubts. Okay, if there are any left still. Fine, let's see. In this example we have a 1 1 here, and there is a propagator. Okay, so it will become 3. 2 plus 1 3, correct? We have a carry here, and it is 1 2 3 4, so it will be 4 plus 1 5 plus 1 6, and we have a carry generator here, no any propagator, so C is 1. Who is the maximum? This is the maximum, so 6 is the answer in this case. Now how will we verify that? How we are going to verify? This is very simple in this question, because the brute force is already provided to us. The algorithm is that is a brute force, correct? That is already provided to us. So just write that code. Okay, take the examples, run it in both the codes, okay, and you will get this, that yes, the answer was 6, and by our method also we are getting 6. So that is the whole case. Okay, in what case will we get a 0? So as you can see here in the question also, they have provided the cases. When b is 0, the answer is directly 0. Okay, and when a is 0, the answer is 1. Okay, so when b is 0, the answer is directly 0, and when a is 0, the answer is 1. Fine, that cases they have already provided to us. We only needed to identify this case. Now how we are going to implement it? The implementation is also very simple. Whenever a of I becomes equals to b of I equal to 1, both are 1, okay, then start a counter, okay, that will count how many consecutive 0 1 pairs are present. 0 1 or 1 0 pairs are present. A counter will count this, okay, whichever counter is the greatest, that is my answer. And that is a simple implementation of the code. I will show you a implementation in C++ also, and a very good trick that for matching the answers. That first I wrote a brute force approach, okay, that is given to us. Second, this logic that came to my mind. Now I write a third code in which a generator, I am using a random test case generator, okay, that is generating these strings. Fine, now I'm passing that strings both to brute force approach and to the logical approach. Okay, when they are returning the values, I'm matching their values. Now if these values are exactly the same, then it's fine. If it is not same, then the question that the program is stopping and printing me for which value of a and b they are not working correctly, for which values of a and b they are not working correctly. Okay, I will show you this part also. First let me show you the implementation of the logical part. Okay, implementation of brute force, you can directly do it, and then I will show you this part also. This is a very important, very useful trick. If you know the brute force and if you know the logic, okay, you think the logic is correct, how to check it? So using a test case generator, fine, and these two things, that is writing these two codes, you can directly do it. Let me just show you these parts. So this one here is in C++. I was using bitset for that brute force approach, therefore I was coding in C++. So I wrote the code in C++ as a whole instead of Java. So we have strings, correct, taking two strings as the input, initializing all the variables that I need, okay, the boundaries, the counts and everything. Then n and m for the string lengths. I am appending I am counting the number of zeros. Why? If b is 0, the answer is directly 0. So if b is 0, that is the b 0 count is equal to the length, then directly print 0, else move forward. Now I am appending the zeros if n is less than m or m is less than n. Just see here. In this case, we appended a 0 at the end, correct? In this case, a 0 was appended at the end because this was 4 digits and this was 5 digits. So therefore, I'm appending a 0 at the end and making n equal to m. Now, just simply, whenever we get two ones together, we initialize our boundary. Yes, from here start counting. That from here start counting. Make count equal to 1, and from at this position start counting. Okay. So when boundary became I, so boundary is not equal to 1 in the next else if condition, check for 0 1 and 1 0 case. If it is, increment the count, increment the max. Fine. Else make boundary equals to -1. When both are zeros, make boundary equals to -1. Okay, and at the end simply print max plus 1. When it is 1, that means a is 0 and b is not 0. That this condition is also satisfied here. Now I want to show you how we can test it out, whether this is correct or not. I will make some changes in the code that will be wrong, and you will see that which case is giving me a wrong answer. Fine, that is an important trick in such type of questions where you know the brute force approach and you want to check your logic is correct or not, or even by thinking you are not getting that which test case actually my logic is failing. And if you know the brute force approach, then you will get this by just watching this right now, which I'm going to show you. I hope the explanation was pretty clear, that we just need to know which carry will propagate the maximum times. So that is the normal explanation. Fine, so let me just show you that part now. So guys, see here, it is very good. So while flag equals to true, okay, I am running it infinite number of times. As soon as there is a mismatch, the flag will become false and it will be over. Okay, now I'm using a string generator, random generator. Okay, I'm creating a string of length 20 and string of length 30. Let me change it. A string of length 6, both are 6. Okay, containing 0 and 1s only. Then here So this is for the brute force approach. It will return me a value. It is an optimal approach that will return me a value. If they are not equal, print me for which values of a and b they are not equal, and what are the values that they are returning. What is the difference? Okay, make it false if they are not equal. So right now they will be equal. So let me just make some changes here. So I will not handle the case in which this one. I'm not handling this case now. Okay, fine. I'm not handling this case now where b is equal to 0 and a is not equal to 0. That means it should return a 0. Okay, now in this case I'm not handling that case now. Okay, and now while I run it, it will run till the point it finds such strings that will mismatch. Till that point it will run. Okay, and this is the brute force approach. As you can see, this is the same one. While b is not equal to 0, I'm just using bit set here. Okay, and it will run that many number of times. Fine. So it is running right now, it is building. Let me just show you that part also. See here. So it shows me that for a this and b this, the brute force is returning a 0 and your optimal approach is returning a 1, which is wrong. So you need to handle such case. See, now you found out a test case for which it is not working. So this is a good trick. Okay, this is a really good trick. Fine. So when I handle it, so I am handling this case now, correct? So let me just unhandle some other case. So I am not handling the case where the boundary will again reset when both are zeros. Now I am not handling that case. Okay. Now while I run it again, the brute force will definitely give me a correct answer. Correct? Now, so for checking, there is no time limit. So it can run any number of times he wants. The brute force will definitely give me a correct answer. Okay. But right now, what I am doing is I am just not handling few of the cases. Okay, because in the beginning we may not handle all the cases, but using these test cases, then after this, yes, oh, I understood that I'm not handling the case where all b's are zeros. I'm not handling that case, so we need to handle that case. Now let's see, for this one it gives me a 3 brute force and my code gives me 4, so that means I'm not handling this case. So on a pen and paper, just check what is happening, just dry run your code and check what is happening, which case is not handled, then handle it simply. Okay, so this is one of the way. And this is not this JNGEN. You can search this on the GitHub. Okay, he has provided a very good this random test case generators. Okay, for strings, arrays, trees, everything, graph also. Fine. So you can find it on GitHub. Okay, so this is how, if you know brute force and if you have written a logic and you cannot find out that which test case is not running, you can find the test case like this. Okay. So this was how this question was solved. Thank you.